Hello everyone. Let me get the technology figured out here. We are going to give you a little video on solving some problems from section 4.8, which is called Applications and Models. At the beginning of 4.8, it has some questions where it just says solve the right triangle. And what it means when it says solve the right triangle is that each triangle has really 6 parts. It has 3 angles and 3 sides, and it's common to just label the side opposite the angle with a lowercase letter, and of course it's common to label each vertex or angle with an uppercase letter. And so here's a common picture here, and you can see that it says solve the right triangle, where C is the right angle, angle A is 42, and side C is 10. And so what we're asked to do here is to find side A, side B, and angle B. Now angle B, is pretty easy here. We could say that it's 180 minus 90 for C, and then minus 42, and so that's 48 degrees. Okay. Now for side A and side B, we're going to need a little trigonometry. And so, for example, you might think to yourself, well, I know side C is 10, and so that's the hypotenuse. And so I could say that the sine of A is A over C, which is to say that the sine of 42 degrees is A over 10. And so A is 10 sine 42. You're going to want to make sure that you're in degree mode on your calculator. And we need to hit 10 sine 42. And that's 6.691 to the nearest thousandth. Okay, and so it's also true that we need to find side B. We can do that actually with the Pythagorean theorem if we wanted to, or we could do some more trig. And so we might say that the cosine of 42 is B over 10. And so 10 times the cosine of 42 is B. And so if we get on our calculator here, we get this number, 7.431. Again, we could have done either of those with the Pythagorean theorem once we had one. So like, once we had 10 sine 42, we could have just hit the square root of 10 squared minus that number squared. And that way we would have got our answer that way as well. Okay? All right. So that was one type of those. Another type is where we're asked to find angles, and so this is why we just did that section before on inverse trig functions. And so again, I'll just draw a picture here of some generic triangle. I'm not trying to draw it to scale or anything. This is A, B, C, and we're saying that A is 7 and that B is 9. Okay, so for one thing, C, is found with the Pythagorean theorem, and so C is the square root of 49 plus 81, so that would be the square root of 130. Okay, 130, let's see, that's 5 times, or better yet, that's 65 times 2, so that's 2 times 5 times 13. That's as far as it simplifies, but we probably want this in a decimal form. And so that's about 11.402. Now, as far as finding the angles go, we're going to want to do something like this. We'll say like tangent A is, A over B, which is 7/9. And so that means that the tangent inverse of 7/9 is equal to A. And so we need to get our calculator out here and put tangent inverse, so second tangent, 7/9. And that gives us 37.9 degrees or so. And then, of course, angle B is the complement of that, so we can just hit 90 minus that number. So we have 37.9 and 52.1. So A is 37.9 and B is 52.1 degrees, of course. Okay. All right, so maybe let's do one of the story problems, just so that you have some experience with a story problem here. So let me find one in your book. How about number 22? It says an observer in a lighthouse 350 feet above sea level observes two ships directly offshore. The angles of depression to the ships are 4 and 6.5. How far apart are the ships? Okay, so let's draw this picture here. And so remember, we talked about this maybe one day. The angle of depression is this angle where if you're at the top of the tower, it's the angle from that horizon, that horizontal, down. And so if there's a ship over here and its angle of depression is 4 degrees, and then there's a ship here. I am not drawing this to scale at all. And then this angle here, that whole thing, is 6.5 degrees. And they want to know this distance between the ships, so we'll call that x. And we do know that the height of the tower is 350 feet. Okay, so let's get this book out of the way here. Okay, so, if this angle is 6.5 degrees that I'm pointing at with my pencil, then it follows that this angle is 6.5 degrees because of alternate interior angles of parallel lines cut by a transversal are congruent. In a similar way, you could argue that this is 4 degrees. This one and this one, should be congruent. Okay, so now that I drew that one in, it almost looks like I should switch my angles on the picture. That one just feels better, doesn't it? Yeah, I think that feels better on the picture. Anyway, this angle is 4, and this one is 6.5. The decimal point's not showing up very well. There we go. Okay, so in order for us to do this, I think we should introduce a new variable to the problem. We'll say that one is y. We've had some problems like this before, and so we could say that the tangent of 6.5 is equal to 350 over y. Okay. And we could say that the tangent of 4 degrees is 350 over x plus y. Okay. Now, so, it follows that we can find y relatively easily here. We can take 350 divided by the tangent of 6.5. That'll be y. And so 350 divided by the tangent of 6.5. That's that number there. And that's y. And so let's just go ahead and store it. So hit the stow button, and then hit alpha, and then hit y. All right, and so that'll be y. And then in a very similar way, we know that the x plus y is 350 divided by the tangent of 4. Okay, and so 350 divided by the tangent of 4, that's x plus y. Okay, and so if I just take that number and subtract y, then I should have x. And so our answer here is 1933.322. So maybe I'll write down some numbers here. Y was about 3,071. 0.9 x plus y was about 5,005.2, and so that means that x is about 1,933.3 feet. All right, so that was that question in the textbook. That should help you get started on some of your homework. Hope this helps. See you soon.